Hello, everyone, and welcome back to Scitame Learning. When you hear the word museum, you probably think of paintings, dinosaur skeletons, ancient artifacts, or space capsules. But today, I want to show you something different. Every museum is actually built on mathematics. Without math, there will be no exhibits, no buildings, no lighting, no visitor planning, no preservation, and no way to organize millions of objects. Today, we are going to discover the hidden mathematics of museum. Let's begin. How big is a museum? The average museum, let's say in the US, roughly occupy 25 to 60,000 square feet. You know, for example, a neighborhood museum may be 15,000 square feet. A regional can be 50,000, and a major national museum can exceed 500,000 square feet. But for the sake of argument, let's come back to Washington, D.C. and examine the Smithsonian National Museum of Natural History. It happens to be one of the most popular museum in uh, in the U.S. and, as a matter of fact, in the world. Every year, millions of people walk through its door to see dinosaurs, fossils, gemstone, mummies, and the famous Hope Dam. But today, let's look at it through the eyes of mathematics. The museum contains approximately 1.5 million square feet of space. That's big. Um, Suppose the building were approximately 1,500 feet by 1,000 feet. So it is about 1.5 million, right? Square feet. That's roughly the total floor space for the Smithsonian National Museum of Natural History. So this is the Smithsonian National Museum of Natural History. Now imagine trying to organize millions of specimens, hundreds of exhibits, and channeling thousands of visitors, host hosting, having restaurants, gift shops, research laboratories, and storage rooms inside one mathematical design. Without geometry, measurements, and careful planning, a museum this large simply couldn't function. How many objects can a museum hold? Here is something surprising. The exhibits you see represent only a tiny fraction of the museum's collection. Many museums display only 2 to 10% of what they own. So 2% to 10% of what actually the museum owns. Suppose a museum owns 500,000 artifacts. If only 5% are displayed, so that's 500,000 multiplied by 0.05. That's roughly 25,000 objects. That means 475,000 other artifacts remain safely stored. Imagine visiting your favorite museum for every artifact you see. There may be 99 more hidden behind the scenes. That's mathematics helping museums preserve history. Let's look at the geometry of exhibits. Museums don't randomly place displays. Everything is measured, Suppose each exhibits need a 10 by 10 feet. That's about 100 square feet. If a gallery contains 12,000 square feet, then 12,000 divided by 100, that's about 120 exhibit spaces. But designers also need space for visitors to walk. So they have hallways, emergency exit, wheelchair accessible area, groups, security, and so forth. So mathematics helps determine the perfect balance between exhibits and open spaces. Now, why don't people bump into each other? Museums are really about moving people efficiently. So suppose 600 people or 600 visitors arrive during 1 hour. That's 600 divided by 60 minutes. So that's 10 visitors per minute. If each visitor spends 2 minutes at every exhibit, so exhibit, engineer can estimate how crowded each gallery becomes. This is called visitor flow. The same mathematics is used in theme parks, airports, stadiums, and even grocery stores. Museums become giant moving math puzzles. The science of preservation. Old paintings, paper, wood, cloth, all change with temperature. Museums constantly measure temperature, humidity, light, air quality, to name a few. Imagine a room stays at 70 degrees Fahrenheit with a 50% humidity. Even a small change of 5 degrees or 10 degrees of humidity can slowly damage priceless artifacts over many years. Mathematics allow museums to predict these changes long before people notice them. Lighting is math. Too much light fades paintings. Too little light makes them impossible to enjoy. Suppose one painting needs 150 units of light. Another needs only 50 units of light. Engineers calculate distance, angle, brightness, reflection, and shadows. Even where a spotlight is placed is solved using geometry. The goal is simple: protect history while helping visitors see it clearly. Building a safe museum. Museums are designed to protect both people and priceless collections. Architects calculate the weight of giant dinosaur skeletons, stone statues, glass cases, and millions of pounds supported by the floors. Imagine a fossil weighing 2,000 pounds. Can the floor safely support it? Engineers answer that question using mathematics long before construction begins. Without those calculations, the museum itself wouldn't be safe. Now let's attack today's museum math challenge. Suppose a museum owns 2 million artifacts and only 3% are on display. How many artifacts can visitors actually see? Pause the video, please, grab a calculator or solve it mentally. The answer should be 2 million multiplied by 3%. That's about 60,000 artifacts. Which means 1,940,000 other artifacts are preserved behind the scene. They are not, people can see them. In conclusion, today we discovered that museums are much more than buildings full of stories. They are filled with mathematics, geometry, designs the rooms, arithmetic organizes collections, statistics predicts visitors, engineering protects priceless treasures, climate science preserves artifacts, optimization improves every visitor's experience. The next time you walk through a museum, look beyond the exhibits. You will discover that mathematics is quietly working everywhere around you. If you enjoyed today's episode, please like, subscribe, and share this video with somebody who enjoys museums. And here is today's DMV Math Challenge. Which museum in Washington, D.C., Maryland, or Virginia do you think uses the most mathematics behind the scene and why? Leave your answer in the comments. Until next time, keep discovering the mathematics hidden in everyday life. See you in the next episode.